Graphs. Exam preparation examples part 1. Before you start with these examples, first go through all the basics in the grade 10-11 part 1 mathematics textbook y equals mx plus c to success, and you will find it from page 236 to page 272. Now, this is also from the textbook. And this is the summary that you will find. Okay, so just know the basic of the functions, or know how the basic functions look like. So a constant function is, for example, y equals 4. It only cuts the y-axis and it cuts at 4. If it's y equals negative 2, then it will cut there at negative 2. That's a constant function. A linear function is like y equals mx plus c. So it will go through, it's a line with a gradient. It don't have to go through the origin. It can go anywhere. Okay, so this is a positive gradient and this is a negative gradient. And then a quadratic function, a parabole, and this will be x to the power of 2. Now again, if there's something else, say plus 2x plus 3, then the graph can go like this. Now this is a positive, so if there is in front of the x squared, if there's a positive, then the graph will be a smiley face. And if there's a negative, then it will be a not smiley face. Okay, but you can go through in the textbook through the basics. And then a cubic function, that will be x to the power of 3. Now, if it's the basic one, otherwise it will go like this. And again, if it's positive, then it will go first the gradient positive. And if it's negative, then it will first go negative. So then it's negative x to the power of 3. And then a reciprocal function. This is where x is at the bottom. So it's not cutting the y and the x-axis. It's just striving to it. So it can be 5 over x, 4 over x, just like this. And then if it's now, say for example, it's now a square. So it's a negative 2 or 3x2, then it's looking like this. Okay. And then an exponential function, this is where the x is in the exponent, then it's looking like this. And it can also become negative if it's a negative there. Okay, and then gradients of curves. So if I have a function and I draw a tangent to that parabole or a quadratic function, then if I want to find the gradient at that specific point, I can just take 2 points. There's my 2 points. And then I get the difference in y divided by the difference in x. Okay, but let's look at examples. That's the purpose of this video. Okay, so let's first. Now, this is the first type of question that they can ask. They say, on the axis, sketch the graph of these functions. Okay, so if you have a basic idea, that's very good. But I prefer that you also make a small table just to be a little bit more accurate in your sketch. So if it's 2, you can see this is a reciprocal function. So you can construct a table to help you with the sketch. So what I just do is I just construct a table. For me, it's just helping me with the sketch. Although if you just do it nice and neatly, that will also be fine. So just if I just go in there, 2 divided by negative 2, so it's negative 1. 2 divided by negative 1, so it's negative 2. And then I just plot my points and I just draw the sketch. I think it's just helping you, and it can be you can actually, yes, just 2 points on this one and 2 points on the other side. And then if it's going to be 2 to the power of, and I just want to make it bigger that you see better. This is 2 to the power of negative x. Do you see the negative there? So now again a sketch will help you. So then I go 2 to the power negative 2. Okay, and I'm just, and if you substitute it, I'm just going to do 1 for you. 2 to the power, okay, but now remember it's negative 2. So it becomes 2 to the power positive 2, and that's why it's 4. And if it's, say for example, in this case 1, so it's y equals 2 to the power negative 1. Then just go and take it from the top to the bottom, and that's a half, and it's 0.5. Okay, So basically, and then I just plot my points and I just draw my curve. I think it's just to make 100% sure you are getting your full marks in this question. Okay. I want you to do the same as in other videos. I want you to stop the video and I want you to do number 1. And as soon as you did A, B, and C, then you can continue the video just to make sure that you are correct. But okay, let's start with the examples. Try now number 1. So try now number 1. Okay, let's start with number 1A. So sketch the graph of each function. Now, if you look at A, this is a linear function. Can you see that? Okay. It will cut the y-axis at -3. But just to be a bit more accurate with your gradient, let's construct a table. Now, what I'm going to do is I'm just going to work on the grid because that is going to help me a little bit. Okay, so if I'm just going to make quickly a table. Okay, so let's start. This is my x and this is my y. Now, what I always like to do is at least 3 points. So I can take -1, I can take 0, and I can take 1. Okay, so if I substitute, so if it's -1, -3, that will be -4. And if it's 0 minus 3, that will be -3. And if it's 1 minus 3, that will be -2. Okay, and now I'm just going to quickly take a ruler and draw your axis. Okay, now I'm just struggling a little bit with my linings here. Okay, that's better. Okay, let's just see if I can do that other one also a little bit over. Just want to see if I can use this tool to just move this one. Okay, so basically I'm just going to go and I'm going to say, I'm going to mark it. So this is going to be 1, 2, 3, 4, and this is going to be -1, -2, -3, -4. And this is also going to be 1, 2, 3, 4. This is my y-axis, this is my x-axis. This one is -1, -2, -3, -4. Okay, so if I plot, so it's -1 and -4. I plot there. And then 0 and -3, I plot there. And then 1 and -2, and I plot there. Okay, and then take your ruler. Okay, so let's just find my ruler. There's my ruler. I take it out. Okay, so I can put this away. Okay, I'm just going to get it in position. And then I just turn it a bit still until it's in that position. Okay, it will go there at -3. Okay, if you want, I just want to show you the other method. If you really want to see where it cuts the y-axis, then you use linear programming, where it cuts the x-axis. We know it cuts the y-axis at -3. You make y 0. And if you put there 0, and then it's x minus 3, and then it will also be 3. Did you see if it goes over? So I think that line is perfect like it is there. So I'm just going to take my ruler and, oh, sorry, I'm taking incorrect. Okay, I'm taking the ruler, I'm taking my color, and I'm just going to, oh, sorry. Seems to me it didn't take the ruler. Sorry, I'm just struggling a little bit with my technology. Okay, want to get it now correct. Okay, and again, due to the technology, I'm struggling to go very close to this point. So it's like I must start very close. Otherwise, it's not going to be accurate like that one. Let's see if I do it from the top. Okay. Okay. But it cuts there at 3 and there. And now I'm just going to get my technology away, which really made it a bit more difficult. And then you can just write y is equal to x minus 3. And if they want, you can always say this is 3 and 0, and this is 0 and negative 3. Okay, you can do that also. But it's not necessary, it's not saying that you have to indicate that positions. Okay, that's the first one, number A. Let's go for number B. Okay, let's take another color, number B. So if you already write it down, you can see, oh, this is a reciprocal function. This is very nice. So the first thing I'm always doing is I construct a table just to help me. You know already how the reciprocal looks like. Yeah, I think it's long enough that I can just not use all of them. Okay. So basically, this is x, this is y. So this is y. Okay, so again, I'm just using a few points. So make it -2, -1. You cannot have 0. So 0 is scratch. And then you can make 1 and 2 because division by 0 is undefined. So it's 1 divided by -2, and that's -0.5. And then 1 divided by -1, and that's -1. And then 1 divided by 1, it's 1. And then 1 divided by 2, it's 0.5. And again, I'm going to make my axis. Okay, this line was better. Okay, and I move it up a little bit. And I start plotting. Okay, again, I can first keep to my color. And this is, I'm going to, because it's in 0.5, I'm going to stretch out the scale a little bit. So I'm going to call this -0.5. And then this is -1. And then it's, yes, it's basically, I just need that too. So this is 0.5 and this is 1. And then, oh, that is the x-axis. Okay, so let's just go on. I'm going to just, then it's -1.5, and this is -2. And then this is 1.5, and this is 2. Okay, and then on my y, definitely, it's 0.5, and it's only up to 1. And it's -0.5, and it's -1. This is my x-axis, this is my y-axis, and I'm starting to plot. So -2 is -0.5. -1 is -1. And then 1 and 1. And then 2 and 0.5. And now, remember, that's why it's very good that you have the basic shape in your mind. Because it's going through, but it's driving towards that axis. Okay, and that's y is equal to 1 over x. And that's your reciprocal function. Okay, let's go for the final one in this question, number C. Okay. Number C. And that is y is equal to 4 to the power of x. Okay, that's an exponential function. So it's an exponential function. Okay, so basically you can again construct your table. It's always helpful. Oh, I don't like lines that's not straight. I like straight lines. Okay. Okay, so basically, if I'm going to look here, sorry. Okay, so this is x, this is y. Okay, and now I'm going to construct my table. So if I make this -1, and I can make this 0, and I can make this 1. So if it's y equals 4 to the power -1, it's 1 over 4 to the power 1, which is 0.25. And if 4 to the power, anything to the power of 0 is 1. And then 4 to the power 1 is 4. And again, I make my table. I'm just going to use my yellow. Okay, let's just... Okay, and then I'm just going to sketch and make it -1. So just to make it a bit wider, I'm making this -1, and this I make 1. Okay, and then to get this scale, I can make again this 0.5. The scale, the x-axis and the y-axis, the scale don't have to be the same. So this is 1, this is 1.5, okay? But now you must just remember that one is going up to 2. Oh, so I'm going to rather redo it because I see it's now... I'm just going to... So this is my x, this is my y, and I'm rather going to make 1, 2, 3, 4, because now I'm going to have -1 and 0.25, say there. And then I have 0 and 1, and then I have 1 and 4. And then I'm just doing this. And then this is y is equal to 4 to the power of x. And this is my exponential function. And this is how you do number 1. Let's go to number 2. Okay, number 2. Okay, show that, okay, I can see this is a cubic function, can be written as this. Okay, so they like bringing algebra a little bit in, but you are good in algebra. So let's just do a little bit of algebra. We're just going to multiply out the brackets, and that's easy. So what we do, we can first rewrite the first one, and then first multiply out the last two. So 3 times 3, that's 9. 3 times x, it's 3x minus 3x minus x squared. And then if I'm looking at this one, I just want to show you, this is cancelling out. Did you see that? So basically, x times 9 is going to be 9x. X times negative x squared, so it's negative x to the power of 3. And then this 1 times 9 is 9. And then 1 times this is negative x squared. And that is going to give me, okay, now I can just arrange it from the number. So it's 9 plus 9x minus x squared minus x to the power of 3. And if I look, it's exactly as it stands there. Okay, so I must come to that answer, not use it. Now sketch the graph indicating the coordinates of the points where the graph crosses the x and the y. So now it's very important that you mark that positions. Okay, so if you're going to sketch, so if I want to see, and I just want to show you, if I want to see where it cuts the x-axis, I'm just showing you, I can already see it there, then I make y0. My y0. So if I'm going to, I put 0 in the place of y, and I have x plus 1, 3 minus x, use the brackets, they helped you. So put this, it's either this bracket that's 0, or it's the second bracket that's 0, or it's the third bracket that's 0. So it's x is equal to -1, or if it goes over, x is equal to 3, or x is equal to -3. Okay, so when I want to see where it cuts, and I can already see it, I can then use this one. When it cuts the y-axis, I make x 0. Now, you use this one, as I said. Use the one it's going to be easier to work with this one. It's just, I think for me it would be easier. Okay, so I'm going to put in the place of x 0. So it's going to be y equals 9 plus 9 0 minus 0 squared minus 0 to the power of 3. So therefore, the value of y is equal to 9. Okay, and now I can go for the sketch. Okay, so let's just... Now, can you remember what I said? Because it's negative x3, the graph will first go, the gradient will first go down. Okay, so let's just put everything on a sketch there. So again, I'm just going to make my axis, and in this case I'm going to rather keep with definitely not without a ruler. Okay, and now I just want to really see that my scale is fitting. So if it's going to 9, I see 9, I see -1. So I think with the x scale I'm fine. With the y scale, maybe I can go 3, 6, 9, because I just need that 9. So I can go 3, let's just get my pen correct. I can go 3, 6, 9, this is my x, this is my y. I can go -3, but it's not going to, I'm not going to influence here, -6, but -9. And then I'm just going to go, I can go 1, 2, I'm rather going to go 2, just to be a bit more stretch. 1, 2, 3, because it's only to -3. And then this is -1, -2, -3. Okay, and now I'm going to start with the sketch. Now the first thing is mark all your points. So it's going to be go through this point. It's going to go through -3. There, I see it. And it's going to go through that middle one, 3. And it's going to go, cuts at 9. Now, remember what I said with the sketch. Remember, it's going to, we don't have to find the turning points. So it's going to go like, I'm first going to show you before I do. So it's first coming down, and then it will make a turn, and then it will go there, and then it will make a turn again, and then it will go there. Okay, so if I'm going to do, and I'm just going to do it a bit more roughly, so it's going to be like this. I don't know really how low. Okay, and then it's going to go like this. Okay, now they want me to mark this points and write down the coordinates. So they want -3 because indicating the coordinates of the points where the graph crossed the x. So it's -3 and 0, and -1 and 0, and 3 and 0, and 0 and 9. And that was the graph of, and now you can decide if you're going to say 9 plus 9x minus x squared minus x3, or if you're going to use the brackets. Okay, and that's how you do it. As I said, it's just a sketch. It don't have to be accurate, but at least it must go, and it must have the shape and everything. You will be marked on that. And then let's do the final question. Okay, Okay. So the final question is number 3. The equation, and this is again a cubic, can be written as this. Find the value of A. Okay, so it starts again algebra, but again, you are good in algebra. Algebra is for me the basis. So just if you are not so good in algebra, go back to the chapters of algebra and keep on practicing and doing that mathematics. Okay. So this is it's y is equal to x to the power of 3 minus 4x squared plus 4x. Now I can take out a common factor. Can you see that? I can take x out. So it's going to be x squared minus 4x plus 4. And now it's a trinomial, and I can see if it can factorize. Okay, this is group B. So I like 2 and 2 and 1 and 1. So 2 plus 2, that will be 4. The signs will be the same, negative, negative, and x, x. So y is equal to x, and then it's x minus 2, and then it's square. Okay, now they say find the value of A. So therefore, the value of A is equal to, find the value of A. The value of A, do you see there is the value of A? There is the value of A. That's a negative, so it will just be 2, not negative 2. Otherwise, due to the fact that they said, can I just show you? I want to write it in here. They said y is equal to x minus, they already have the minus, and then A, and then square. So basically it's just 2. If it was a plus, you could have said negative 2, but the sign stays the same, so it's just 2. Okay. And then they go and they say, sketch the graph indicating the values where the graph meets the axis. Okay. Now be careful. If you know that if it's a double bracket, then it's meaning that if you work it out, you will see. Okay, now let's put it in bracket. Let's do it exactly like we did the previous one. So just for understanding, where cuts the x-axis, make y 0. Okay, now let's do that. So if we use this one now, so we have 0 equals x minus 2 squared. So if I go, I can say, oh, it's either x that's 0 or x minus 2. Now it's squared, but it's going to be the same. It's actually like it is 0 equals x minus 2, x minus 2. So you can say it's either x minus 2 or it's just going to give you the same value. Okay, maybe it's a bit just stupid written out but it's more for understanding. So it's 2. It's always that it makes the turning point there. Okay, so it's x equals 2, x equals 2. That is the point. And then when you want to see where it cuts, the y-axis, you make x 0. Now, what happens if you make x 0? So you have y equals 0, okay? 0, I'm working in that one, 0 minus 2 squared. So if I'm going to see there, I'm going to see that I'm going to have, but the problem is, although you get there, you get negative 2 squared, but I just want to move up. What happens is that you multiply 0 multiply positive 4, and that's 0. So it cuts the y-axis at 0. Okay, so it's a bit a difficult one because it's having very simple values. Okay, but let's go and make the sketch and take it from there. Okay, so first let's just get our 2 axes. Okay, And then I'm going to go with this one, and this one is 0. Okay. This is 0, and this is 1, 2. Let's make this 2. Okay, because that's all we need. Now, can I just go back to the function? If you go back to the function, you will see it's positive x3. That means the gradient will first go up. Okay, so say I'm going to be there, and it's going to make the turning point there. Did you see? And the gradient will go up. Okay, so let's put everything together on that. So it's going up, it's going through here, and then it's going to make a turning point there, but then it's coming down and it's making a turning point again there. Do you see? I can even try to make it a bit smaller. So it's like this and like this. Okay. It's almost every time that I just want to move it a little bit more, that it's more turning there and then turning there. Okay. And then it's just going to be y is equal to x3 minus 4x squared plus 4x. And don't forget to say 2, 0. And don't forget to say 0, 0. Indicating the values where the graph meets the axis. Very important. Okay. And that's how you do it. That's how you do the sketch examples. In the next video, we will go further in graphs. A final note. Most of the videos on this channel feature examples from the Y equals mx+c to Success mathematics books. Try your best to purchase your own hard copy from one of the following bookshops. This will enable you to highlight and make personal notes in your own textbook. And remember, the only way to learn mathematics is to do mathematics. Best of luck.